In this video, I want to show how we can evaluate a limit numerically, that is using our graphing calculator. And so we have these 8 problems here. We'll see how many that we can do in the time that we have. So we're going to look at number 1. We want to go into y equals, and we need to put in parentheses x minus 4 divided by parentheses x squared minus 3x minus 4 close parentheses. And so we have our function in there, and just want to double check x minus 4 in parentheses divided by x squared minus 3x minus 4. Then we're going to go into the table set, which is second and window, and we need to make sure that we set independent to ask, like so, and then we can go into the table, second, table. The independent ask function allows us to specify the x values that we want to see y values for. Otherwise, we put in a starting value for x and set a delta table, which restricts the or regulates the x values that the calculator shows. So if you started at 1 and you had a delta table of 1, it would go 1, 2, 3. If you started at 0 and had a delta table of 5, it would go 0, 5, 10, etc. But we want to put in the values that we're interested in, and so we're going to use independent ask. So we go into the table now, and we're going to be able to type in these values, 3.9, and we see that we have 0.20408. And next we have 3.99. Now with delta table we couldn't get this kind of value. We could go 3.5 to 3.6 to 3.7, but we can't get these increasingly more detailed numbers, 3.9, 3.99. So there we have 2.004. Sorry, 0.2004. So we'll write these numbers to 4 decimal places. In the previous one I rounded to 0.2041, then 0.2004, 3.999 gives us 0.2000. And so then we'll start from the right side. So these are values approaching 4 from the left side. Let's approach 4 from the right side. And we'll type in 4.1. We're starting all the way over to the right, and that's 1.96 rounded to 4 decimal places would be 0.1961. And then we'll do 4.01. That's 0.1996. And finally 4.001. And that gives 0.1999. And if we were to round that to 4 decimal places, that would go to exactly 0.200. So we're right about there. So right there where x would be equal to 4, we get a limiting value of 0.2. Now if we just wanted to see, what we should always do before we even go to this is that we should plug in 4 into the function. And you can see from this, if we actually did plug in 4, we would get an error that there is no value. 4 minus 4 is 0. In the denominator, 4 squared is 16. Minus 3 times 4 would be 12. 16 minus 12 is 4. And 4 minus 4 is 0. So this would give us a 0 over 0. We couldn't just plug the value 4 into the expression, but by taking the limit, we can see where the function is heading from the left and from the right as the x value approaches 4. So once again, even though the value of this expression doesn't exist when x is equal to 4, we can see that the limit tells us that there would be a hole at x equals 4, y equals 0.2. And we'll do another one or two in the next video.